These are notes 8.1, the mole. We are going to describe methods of measuring the amount of something. We're going to define Avogadro's number as it relates to a mole of a substance, and we're going to use the atomic mass to perform unit conversions for individual elements. We will do mass to mole to mass, and grams to number of particles, which we really talk about atoms as particles, and number of particles to grams. So some going grams to moles to atoms, and some of going atoms to moles to grams. We always have to go through the mole hole to get from either grams to atoms or atoms to grams. We cannot go directly to grams or atoms. We need to go through the mole. So what is a mole? A mole is this number here, 6.022 E23, or times 10 to the 23rd, and is that many items. So it is a 6 essentially with 23 zeros after it. It is a ginormous number. So if you were to have a mole of M&Ms, it would cover the earth to a depth of a mile and crush us all. If you were to have a mole of basketballs, it would make a planet about the size of Earth. So as you can see here, a mole is a ginormous number. And when we, again, talk about moles, we talk about molecules or atoms or individual elements. We don't usually talk about other items. And since a mole covers or encapsulates so many items, instead of counting those items, we count by weighing. And the weighing piece comes in from the periodic table. We will use the mass from the periodic table for each element to help us count how many atoms there are. So the mole is really attributed to Amedeo Avogadro, and this number, again, the 6.022 E23, is called Avogadro's number. So let's review. So a mole of items would be 6.022 times 10 to the 23rd items. A dozen would be 12, a pair is 2, a hat trick is 3, a baker's dozen, if you're lucky, is 13. But if you were to have a mole of hydrogen atoms, it would be 6 times 10 to the 23rd hydrogen atoms. It would be Avogadro's number. So the mole and the periodic table. Are you getting dizzy yet? Because I am. Straighten me up. So the mole and the periodic table. If you had a mole of gold atoms, you would have close to $11,000. Sheesh, how did I figure this out? Well, I looked at the periodic table and found that gold has an atomic mass of 197 grams, and the mass equals 1 mole of gold atoms. So 197 grams of gold is that many atoms of gold. And then I searched for the current dollar amount of 197 grams of gold. So it's like $11,000. Holy moly. So the atomic mass for each element on the periodic table represents 1 mole of that element. So if you had 1 mole of helium atoms, it would weigh that amount because that's what helium's atomic mass is, and you would have that many helium atoms. If you had a mole of carbon, it would be 12.01 grams, which would be that many carbon atoms. So notice we have 2 conversion factors here. 1 mole equals 12.01 grams for carbon, not any other atom. Or we have 12.01 grams equals 6.022 times 10 to the 23rd carbon atom. So we get some conversion factors here that we can use to solve chemistry problems. So molar mass. Molar mass is usually attributed to the mass of compounds or molecules, but I'm going to use it in general to talk about the mass that we will use when doing mole conversions. So if you were to have 1 mole of helium, it would have that many atoms, and it would have that mass. I got that mass from the periodic table. So on the periodic table, the mass of each of these elements represents 1 mole of that element. And it makes sense, for example, from helium to carbon, that the mass increased because carbon has more protons and neutrons. So again, 1 mole of each of these elements always equals Avogadro's number, but the mass is different because the masses on the periodic table for each element is different. So if you were to have 2 moles of helium, you would just multiply Avogadro's number by 2, and you would multiply the mass by 2. If you had 3 moles of carbon, you would multiply Avogadro's number by 3 and the mass by 3, and so on. So we're going to do some molar mass problems. Actually, I'm going to just skip to mole conversion factors. So 1 mole of something has the molar mass, and this molar mass is from the periodic table, and you can write it in this direction or you can flip it. The molar mass of a particular element has 1 mole. And then if you want to go from moles to atoms, you would use this conversion factor that has moles and atoms. There, for 1 mole of whatever element, there's that many atoms. Or you could have 6 times 10 to the 23rd atoms is 1 mole. So mole conversion pathways. I like to think of pathways. For example, this first set here, grams to moles to atoms. This is one way to go. GMA, grams to moles to atoms, Good Morning America. Or you could do the reverse, atoms to moles to grams. That would be AMG. And notice, again, you have to go through moles each time. The moles are in the middle. So this pathway, the first one is grams to moles to atoms. I forgot my arrow in there. I'm sure you hear the lovely Seattle sirens. And if you were given atoms and wanted to go to grams, you would do atoms to moles to grams. So if you're going to do grams to moles to atoms, you divide by molar mass, which is from the periodic table, and then you'd multiply by Avogadro's number. And if you wanted to break it down into one-step problems, grams to moles, you really are just dividing by the molar mass, which is the mass on the periodic table. And if you want to do moles to atoms, you're really just multiplying by Avogadro's number. Now, if we were going to do the reverse, atoms to moles to grams, we divide by Avogadro's number, then multiply by molar mass. So they're the reverse of the math that we did up there. So if you wanted to do one-step problems, just maybe given atoms and go to moles, you would divide by Avogadro's number. And if you were given moles and wanted to go to grams, you multiply by molar mass. So let's look at some of these problems that are from your WebAssign, or maybe from your WebAssign, depends what year you're watching this. So this problem here says there are blank chromium atoms present in 52 grams of chromium. Sometimes these will seem like trick questions. So what you want to do is find chromium on the periodic table, and you want to find the mass of chromium, and you will find that the mass of chromium is 52 grams. So that represents 1 mole of chromium. Well, if that represents 1 mole, we know that 1 mole has Avogadro's number worth of atoms in it. So the answer is there are 6.022 E23 chromium atoms present in 52 grams of chromium. Let's look at the next question. So question 2, use average atomic masses to calculate the number of moles of the element present in each of the following samples. Be mindful of sig figs and other units. For example, milligrams must be converted to grams before you can convert to moles. So you always have to have grams, and you almost always have to go through moles to get to atoms or whatever the question is asking. And the number of sig figs that you start with is almost always the number of sig figs that you'll end with. So 4 sig figs starting here, 4 ending there, 4 starting here, 4 ending there. And I see down in this one, there's 3 sig figs, so you would end with 3 sig figs. But let's go back to A. It says 66.57 grams of fluorine, and we want to change those to moles. So we're going to go from grams to moles, so G to M. So we'll have 66.57 grams of fluorine. I like to write the element in there because it tells me where to go look for it on the periodic table. I'm doing my little railroad tracks. This is a one-step problem. I'm going to repeat the grams down here, and it's fluorine because I'm going to cross them off. I'm getting rid of that unit, and I can go directly from grams to moles. For all the problems that you're going to do through this set of notes right here, the mole will always have a 1 in front of it. And so we go to the periodic table and we look up fluorine, and it says it's about 19.00 grams. In my calculator, I'll do 66.57 divided by 19, and that's going to give me 3.504 moles. This next one's a little bit trickier. It gave us milligrams, so we're going to have to go milligrams to grams. I think I'll write it down here. So we'll do 403.8 milligrams of mercury, and mercury's Hg, Hg is mercury, that's the way it ought to be. And we're trying to go to moles. But we have to get to grams, so we have to get rid of the milligrams That is why I always repeat these. Oh, that's the bell. And I'm going to go milligrams to grams, and 1 gram has 1,000 milligrams. You just have to look at your conversion sheet, or maybe you have that one memorized. And then that would help me cross out my milligrams, and now I need to get to grams. I got to get rid of my grams, and I'm going to go to moles. We can go from grams to mole, and in front of the mole is 1, and in the grams in front of that, we got to look at what element it is. It's mercury. We hunt and peck mercury on the periodic table, and we'll do 200.5 grams. In my calculator, I will do 403.8 divided by 1,000. I'll probably hit enter, and then divided by 200.5, and then I'll hit enter again. I should have 4 sig figs at the end of it, and it looks like it is about 0.002013 moles of mercury. So what we did is we changed from milligrams to grams, and then grams to moles, and let me go through there and slay the grams. It makes me feel a little better. In this problem, it says use the average atomic masses to calculate grams. So we're given moles, and we're trying to go from moles to grams. So we will take 0.233 moles, and we will multiply by the mass of lithium. You have to hunt and peck for lithium on the periodic table, and the mass of lithium is 6.941. So you'll do 0.233 times 6.941, and it will pop out with a number, and you need to round to 3 digits, 1.62 grams. This problem is converting from moles to atoms. So it says calculate the number of atoms of aluminum and 32.0 moles of aluminum. So we're doing moles to atoms. So we'll start with moles, 32.0 moles. And when we go from moles to atoms, we really are just multiplying by Avogadro's number. So 32 times 6.022 E23 atoms. And we get 1.93 E25 atoms. We started with 3 sig figs, we end with 3 sig figs. This problem is going from grams to atoms, so we will do grams to moles to atoms, GMA, grams to moles to atoms. So we'll start with 1.33 grams of silver. We will divide by the mass of silver, so 107.9, I got that from the periodic table, and then we'll multiply by Avogadro's number. And that is the final answer. Let's look at the next one. This next one gave us moles, and we will then convert to atoms. So we have 0.0033 moles of copper, and when we go from moles to atoms, we just multiply by Avogadro's number. So we'll multiply those two. We ignore the one on the bottom, and we get that number. This next one is a little bit trickier-ish. Is that a word? We have 1.79 kilograms, and we're trying to get to atoms, so we have to do an extra step. We will do kilograms to grams to moles to atoms, and these will be the units on top, and then to get the units on the bottom, we take that unit, we shift it over to the right, and put it in the denominator. That's my little kitschy way of doing this. So we'll start with 1.79 kilograms of magnesium, and we'll go from kilograms to grams by multiplying by 1,000, and then we will divide by the mass of magnesium, and then we'll multiply by Avogadro's number. And make sure you can do these in your calculator and get that same answer, because you have to use your calculator properly with that scientific notation. This next one says a sample of potassium contains 3.4 times 10 to the 21 atoms of potassium. How many moles? So we're doing atoms to moles, and we'll start with those atoms, and we'll just divide by Avogadro's number to get that number. This next one, what is the mass that you calculated from above? So you can start with the number in your calculator, maybe not that rounded number, and then just to get that mass, you would just multiply by the mass of potassium from the periodic table, 39.10. Let's look at question 7. Question 7 actually is the same as number 6, except for it's with carbon. And that leads us to our last one, which is question 8, which gives you a variety of problems to solve. And each of these wants you to calculate the number of atoms, but you're given something different for each one. So this first one is grams to atoms, so it'll be grams to moles to atoms, the GMA. This next one gives you moles, so you'll just do moles to atoms. You'll just multiply by Avogadro's number. And this next one is another GMA one again. You'll divide by the mass and multiply by Avogadro's number. And this last one is kilograms to grams to moles to atoms. You will probably multiply by 1,000, then divide by the mass of magnesium, and then multiply by Avogadro's number. I hope this helped you a little bit, and next time we will do molar mass.